When Apple introduced Macintosh, we set a new standard for the way computers could make themselves useful to people. That was just for openers. Since then, we've been making the Macintosh personal computer more capable and more versatile. We've expanded our family of peripherals, made it easy to connect with other Macintoshes and other kinds of computers, so that people who use Macintosh have a direct and seamless connection to the resources of any information system. With over 3,000 applications to help people become more effective, more inventive, more productive.
The way most people respond to the Macintosh is to look at it with a sense of wonderment, because they get into the Macintosh and they do things that they wanted always to do, better, faster, and that's fine. But then they get the Macintosh because there were obstacles. There are things that they couldn't do for lack of a proper tool or for a proper instrument. And then they get to write these beautiful documents to prepare these presentations. So they are fulfilling some of their dreams. And then after they've done that, they discover new thoughts because of the new language that we provide them. In other words, once they get over the obstacle, over the mountain range, they discover new territory of things that they can do that couldn't even dream of before they got into the Macintosh.
Macintosh has grown into a general productivity tool with some very impressive specialties, such as helping people communicate with clarity and impact, providing tools for design and modeling, opening new avenues for learning, both on campus and on the job, helping people distill information into knowledge and insight so they can make better decisions, and supporting the programming environments that will help developers around the world continue to extend the range of what you can do with Macintosh. We'd like to show you what's behind the continuing evolution of Macintosh. It's an approach that we call the Open Architecture System Integration Strategy, or more simply, OASIS.
The basic promise of OASIS is that the consistency, the power, the grace, the self-actualization that we provide today with the Macintosh, we can move gracefully into the future using new technology and new software development.
Macintosh is the personal computer that established the advantages of a graphics-based human interface. You control it in a simple, intuitive fashion by pointing to menus instead of having to remember and type commands, and by manipulating screen objects that behave like objects in the real world, all of which gives you a direct and straightforward way to communicate your intentions to the system, and an equally direct way to learn the results.
What we do is we study how people work with tools, and there are a variety of tools that are very successful, such as a pencil or a piece of paper, and then we look at how we can more closely model that successful relationship and then create it as a computer artifact.
With Macintosh, various applications, even from different developers, work in the same clear and consistent fashion. And that leads to a very important consequence. People can combine applications to assemble the precise set of tools they require. Because the ultimate question isn't how easy is it to use, but how much can I do with it? The foundation for this consistency and integration across applications lies in the Macintosh architecture. It's an object-oriented design with hardware and software functions grouped into 5 distinct layers, each layer working with the others to provide users with an intuitive and consistent approach to computing. 2 of these layers are unique to Macintosh, the desktop and the Toolbox. They give users and developers the software components that command the Macintosh experience. And because the entire system is modular, we can improve the components individually, upgrading them to encompass new capabilities, as, for example, when we brought color to Macintosh. We can make these improvements without disrupting the overall design, and more important, without disrupting the way people work with Macintosh. As our technology advances, we add new modules that enrich each layer of the architecture. This strategy of modular extensibility is the key to the smooth and rapid evolution of Macintosh. It's why people who use Macintosh have a direct connection to the future. Every computer system consists of hardware and software. The software is grouped into an operating system and applications. The operating system directs the way an application calls on such basic functions as input, output, processing, and storage. But when it comes to the way users deal with those functions, every application is on its own, which typically has resulted in a hodgepodge of interface ideas. Macintosh takes a different approach. With Macintosh, the user's view of the system isn't an afterthought, it's the central thought. To ensure a rich and consistent computing experience for users of Macintosh, we've moved beyond the typical three-layer model of computer architecture and introduced two additional layers, the desktop and the toolbox. As we'll see, the desktop supports the user's experience directly, while the toolbox gives developers the tools they need to create a diversity of applications that look and feel and work together in a consistent way. The toolbox has a number of components to manage dialog boxes, windows, menus, and so forth. So, for example, when an application asks for a window, it comes out looking and behaving like a Macintosh window. The application can specify how big to make the window, where to place it on the screen, which window should be active, and so forth. The window manager takes it from there. To call up a menu, the application simply provides a list of items, and the menu manager turns them into working menus. And these menus work consistently from application to application.
What the toolbox does is give you a language, a consistent language that everybody shares in, like English, with or without accent. And what the applications on the desktop are poems, novels, stories. So you have a foundation which everybody can count on to communicate, to do things in a standard way. And yet, you have this incredible diversity using the standard language, the toolbox, to do things that do great desktop publishing, great word processors, great spreadsheets, great database programs, great networking devices. So what's very important to our customers and to ourselves and to our developers is the proper layering of what needs to be the same for everything to be harmoniously different.
While the toolbox makes the backstage machinery of Macintosh available to developers, the desktop layer gives users direct control of what happens on stage. The desktop layer lets you manage your system and customize it to your own preferences. Thanks to desktop modules from Apple and other developers, you can get the colors you want, the typefaces you want, or even the calculator you want. Modules in the desktop layer also provide internal connections for bringing data from one program into another, as well as external connections for controlling access to network resources.
At the desktop level, you can arrange your files the way you want on the desktop. The computer will find it for you. You can run an application, write any document you want. The computer will deal with it. You can have any choice of a crazy desk accessory. The computer will deal with it.
A large part also of what our design is to make things very much plug and go, so that people don't have to know a lot about their hardware configurations or how to plug them in to basically make it work themselves. I think one of the wonderful things about the Macintosh is the ability to pull the Macintosh out of a box the first time a user has purchased it and pretty much put it together without trying to fully understand how it works.
The operating system layer connects all of the higher layers to the hardware layer. Macintosh is designed around the Motorola 68000 family of processors. As newer, more powerful processors are developed, we incorporate them into the Macintosh.
These 5 layers give us a sense on how things are architected and work today. But more importantly, they give us a sense on how we can slide a brick out, put a new one, and keep the entire edifice working.
Here's an example of the OASIS strategy in action. Let's roll back the clock and see how the original Macintosh carried out a simple and standard function, reading a file from disk. The user pulls down the File menu, chooses Open, selects a file, and clicks on this button, and Macintosh reads the file from a floppy disk. Here's the way Macintosh processed that request, with components in each layer of the model taking part. The user interacts directly with the application, as we have seen, making a choice from a menu. When the menu selection is made, the application asks the standard file package in the desktop layer to put up a list of files currently on the disk. The user makes a choice, and the name of the file is returned to the application. The application then asks the file manager in the Toolbox layer to open the file, and the file manager in turn calls upon the device driver in the operating system layer, which physically reads the file from the floppy disk so the user can work on it. When our users required large-scale storage capacity, OASIS provided the framework for upgrading. A flat directory system would be overwhelmed by the number of files on a typical hard disk, so we modified the standard file package in the File Manager to support a hierarchical filing system. To the user and to the application, the change was transparent. When you ask to open a file, you have a view of folders as well as documents. Each folder represents a subdirectory, and Macintosh can keep track of the full path to find the document. But for the user, the action of choosing the file is virtually the same.
The advantages that we get over that are that we tend to separate the developers from the hardware. They don't need to know that they're running on a particular type of video card or they're printing to a particular type of printer, because they know that they're always working with the same graphics package, or the same, in fact, Toolbox package or the same operating system package. We'll add a few more calls, but the basic functionality doesn't change.
Each new storage device in the hardware layer is installed with an appropriate driver in the operating system layer, and the File Manager talks to them all. The user can switch drives from floppy disk to hard disk to optical disk and back with a click of the mouse.
It's sort of leave the drivers to us. We tend to basically define an interface for the drivers, and the developer will write a driver to that interface, and we support it. And then the application developer knows he can write to our Toolbox, and we'll continue to support that interface. And we provide the peanut butter that goes between those two slices of bread.
The AppleTalk network system allows applications to access files on a network server. Through AppleTalk, the File Manager has direct access to files and documents at remote locations.
We designed the AppleTalk filing protocol at the same time as we were designing the hierarchical file system of the Macintosh. And we implemented the AppleTalk filing protocol as a close neighbor working hand in glove with the file manager of the Macintosh.
We're continuing to add new modules to the Toolbox to allow Macintosh users to connect with seamless simplicity to a multi-vendor computing environment.
There are more acronyms per square inch in networking than in any other area of data communications. Our job in Apple Computer is to mask that underlying complexity and to preserve the end-user computing experience.
Our objective is to populate the OASIS architecture with networking capability that allows this seamless, empowering extension of the Macintosh user space to resources that are remote, perhaps even across continents.
It is important for people to communicate with one another. That's true in a personal computing environment. I mean, you and I, if we work together, would like to share and exchange information electronically. That's what networking enables. When you take that capability into a business environment, it is important to support the types of connectivity available in those businesses. That's why we get into supporting Token Ring and Ethernet local area networks or wide area networks such as SNA or DECnet.
The OASIS architecture allows us to integrate new network services into Macintosh. But our goal is to assure that the user's view of the network remains simple and direct. Accessing files on any network is no different from accessing files on a local hard disk.
I think Sadhu has the phrase that the Cheshire Cat, you know, the network disappears but the smile remains. I love it.
when we look at the future, what will happen is that there will be changes at each and every layer over time, continuously, without disrupting the entire edifice. That's the key point to remember.
Here's a glimpse into the near future and a few of the ways we'll integrate new technology into Macintosh as we continue to integrate Macintosh into a multi-vendor environment. To handle larger data files and more sophisticated applications, we'll introduce a full 32-bit operating system with virtual memory and multitasking. We'll support inter-process communications and provide a direct way for applications to share data both locally and across networks, giving people better ways to view, analyze, and act on current information throughout an organization. We'll integrate enhanced imaging, video, and sound, as well as 32-bit quick draw, and will extend the ability of HyperCard to access information across networks and through a variety of media, making Macintosh the optimal platform for hypermedia development.
OASIS will help us deliver on a double promise, which is on the one hand, move forward what you have today, bring new applications in a harmonious way, so that technology can be brought in, enhancing as opposed to disrupting. But more importantly, it will help us deliver on our belief, on our commitment, which is to make someday personal computers the most important tool known to man.